Hello and welcome to this quick look at a KP worked exam question. So it gives you an equation for a homogeneous gas mixture for making hydrogen and carbon monoxide from methane and water or steam. So it gives you a couple of bullet points as to what is mixed together in terms of the moles for each of the reactants. And then the mixture is heated to constant temperature and allowed to reach equilibrium, and the equilibrium mixture contains 0.2 moles of CH4 and the total pressure is 30 atmospheres. So they want you to calculate Kp. So the first thing to do is to work out moles at equilibrium. We're going to use the ICE method for this. Obviously ICE is initial change in equilibrium moles. So the question tells us that we've got 1 mole of CH4 and 1.4 moles of H2O. That means we can assume that there's 0 moles of hydrogen and carbon monoxide respectively at the start. It then tells us there's 0.2 moles of CH4 left at the end. So that means it's a subtraction of 0.8 moles. So because CH4 and H2O are equimolar, it's also minus 0.8 from 1.4. So on the right hand side, because you have 3 moles of hydrogen, you make 3 times 0.8 moles. And you have 1 mole of carbon monoxide, so you make 0.8 moles. So applying that across, you now get those mole equilibrium values. Adding them all up gives you 4.0 moles. Next thing to do is to work out the mole fractions and the partial pressures. So the mole fraction is calculated using the equilibrium moles divided by the total, so the total is being 4. And the partial pressure is the mole fraction that you end up with times the total pressure, which you're told is 30 atmospheres. So putting those through a calculator gives us these numbers. So a quick check of the mole fractions will add up to 1, and a quick check of the partial pressures will add up to 30. So what you always make sure your mole fractions add up to 1 to check your maths, and at the same time you check your partial pressures add up to the total pressure. So both of those things are in place, so we're good so far. So we can put those numbers into a Kp expression, like so, and by cancelling the atmospheres, so there's 4 partial pressure terms on the numerator at the top and 2 partial pressure terms on the denominator. So cancelling that through, that means atmosphere to the power of 2. So it's 5184, and checking the mark scheme says first check the answer in the answer line. If the answer is 5184 atmospheres squared, award 7 marks. Okay, hopefully that's been a useful look at this type of question. As always, thanks for listening. Until next time, see you soon.